Hey, good morning, everyone. Welcome to this live sessions. Today's agenda for this live session is to discuss about the entire uh, the flow matrices uh, happening in case of Scrum. As you know, in the IT projects management, as a product owner, you need to define various PBIs, project backlog items. You need to define the roadmap, and then with the help of product project manager in case of sprint planning, we need to uh, fetch that PBIs and define the sprint as per the capacity and velocity matrices plays a role of a team, and we in this manner we define the sprint which is having the certain start date and end date. So now these all the backlog items will be comes to the which was on the high priority will be come to the sprint as per the capacity and the velocity of a team. And then in case that entire PBIs are well explained about the user stories, the the story points and the requisite designs and everything, and it will be assigned uh, to the specific developer or technical expert. So while developing IT projects, while uh, uh, the process is like this. There is a role of a scrum master who perform all the scrum ceremonies, right? Like the sprint planning, sprint executions, sprint retrospective, and everyday scrum meet. So from there, we'll come to know the progress of the project. So today's agenda is to understand each and every importance of the matrix, why it is needed. If we not follow these guidelines, then obviously we will not able to monitor the progress. We will not able to meet up with the timeline by just assigning a task to the developer. Doesn't the topic ends, right? There we need to monitor and control also, and if any kind of technical issues or uh, he not able to deliver the things on time, then you should have a buffer time to take action on it, and ultimate goal is to deliver the things on time. So let us explore these all these stuffs related to the various progress flow matrices related to this scrum. So my team will be giving us the presentation on this all the stuffs, the what are the various terminologies we are using in the product development, in the project development, right from the role of a product manager, product and the project manager and the scrum master and the team, everyone cumulatively, by following these all the scrum rules, or and by obeying all the scrum ceremonies, they'll be meeting the timeline and deliver the things on time. So right from designing to development to testing to deployment, everything is in the this is what agile practice for the product development. And ultimate goal is to deliver the things as per the expectations of a product owner, or rather the stakeholders, right? So it has to be well designed, well developed, and well tested modules can be delivered to the client in that. And then that is what, in that manner, that sprint is considered as a sprint is closed, and then then we'll go to the next sprint. So now every sprint have its own goal, own PBI, and it has to be delivered by the team, right? Otherwise, it will cost to everyone. So over to Team Axiom to understand this all the terminologies what we are discussing over here. What are the various flow matrices occurred in a Scrum, and uh, it leads to successful delivery of the expectations to the stakeholders. Over to Team Axiom.
Thank you, sir. I'm Nutan Surmane from Team Axiom. So today's our topic is flow matrices for Scrum team. See, for a particular planning by Scrum, we need to follow some particular, we can say, a flow regarding the work completion as well as the production. Constant work must be done to turn potential product improvement into tangible customer value. The steps needed to turn a product improvement idea into something concrete that our customer find valuable is called a process here. We have considered Scrum as the framework upon which to build our process for value delivery over here. It's a common misunderstanding that Scrum itself is a process, but it's not a process. It is a framework within which we create and continuously improve a value delivery process with respect to customer point of view here. Now, if we see flow, the movement of potential value through a given process, the other name for process, if we see, known as a workflow. See, we have we if we need to complete some production work, then we have some particular workflow or some particular instruction flow to complete that particular production value. So here is a workflow. There is a reason it is called workflow is because for any process, what really matters is the flow of work, how we can complete, how we can start and how we can complete a particular production work with respect to the particular work. The reason we should care about flow is because our ability to achieve flow in our process will dictate how effective, efficient, and predictable we are as a team as a delivering customer value. Flow comes with a set of basic matrices or a matrix that give us tremendous insight into the health and performance of our process. All metrics are measurements, and all measurements have the same thing in common, a start point and an end point here. Flow is no different. Therefore, to measure flow, we must know what does it mean to work to have started in our process and what does it mean for work to have finished in our process. It's meaningless to not to have a finished date or not to have a finished work. It just started means it's a meaningless work. Usually the item that teams are tracking through to do, like doing then done process are tasks. In other words, most teams will take a product backlog item, that is the PBIs, and break it into tasks like analysis, build, test, check, and fix, and need to complete that one. They will then track the progress of this particular task, small task like analysis, build. They have to track a progress over here throughout the sprint. This is potential problematic because, as has been repeated several times now, flow is specifically concerned with value delivery. But in Scrum, value is defined at the product backlog item level, not at the task level here, which means to use flow metrics in our Scrum context, we must first define what started and finished means for a particular product backlog items. Setting a finished point might be fairly straightforward in a particular Scrum. Just map our finish point to what our definition of done requires for a particular, we can say, PVIs. In other words, most of the time, the finish point in our Scrum workflow would be any time we have added one or more PBIs to our increment, and that increment has met our definition of done over here. But what if your initial definition of done does not include the particular parameter, like that the increment was shipped, that once shipped value was validated, that the value feedback is incorporated into future decision making, and what is our customer want answer to when will it be done in each of those particular cases. The Scrum solution gives a solution with respect to this parameters would be to change our Scrum team DODs of here, that is definition of done, so that it does include those extra criteria into the particular planning. However, organizational constraints may prevent us from changing our team's definition of done to be much broader in scope. Like if we take some example, our teams is not allowed to deploy code to production. It's some others work to deploy a particular code of production, like that only. The beauty is that in this instance, Scrum is not restrictive, rather it is fairly flexible over here with respect to time and planning. Our job as a Scrum team is to deliver value to our customers. Likewise, by choosing Scrum, we have selected a very specific framework upon which to implement a process for value delivery. If we haven't already, we need to sit down with our team and decide there only for our process what does it mean for a specific product backlog, we can say item to have started, and what does it mean for a particular PBIs to have a finish of a particular work or particular task in form of modules. All other flow conversation will be dependent on our boundaries decision. Once defined, the moment of potential value from our defined started and finish point is what is called a particular flow. The concept of movement is of crucial importance because the last thing we want as a team is to start a whole bunch of PBIs but never finish them. Previously, this is a particular bunch of PBI started but never finished them with respect to the bunch if we take here. That is antithesis of value delivery. What's more, as we do our work, our customers are constantly going to be asking, and sometimes they are tracking our work, whether we like it or not. Questions like how long, how many are there, such kind of question we need to understand, and which require our understanding of movement to the answer. That's where flow matrices come in the picture. And if we see a basic matrix of flow, there is a VIPs, there is a cycle time, there is a WIA, and throughput as here. So are here. So WIP, if we see work in progress, the number of product backlog items started but not finished. We need to take analysis regarding our we can say works and sprints. Cycle time, the amount of elapsed time between when a work item started and when a work item finished. Work item age is here, it's amount of elapsed time between when a work item started and the particular current time. Throughput is here, the number of PBIs finished per unit of time. And note here, the measurement of throughput is the exact count of PBIs which we available with us. Now, if we go one by one, work in progress, it's a generic definition of work in progress is a given flow context is all discrete unit of potential customer value that have entered a given process but have not finished yet or not exited yet. In a Scrum context, the discrete unit of work are called product backlog items, that is our PBI. So to calculate work in progress, we simply count the PBIs within your process boundaries as defined above, we can say. That's it. Just count PBIs and we will have calculated our work in progress, we can say count. or a measure of WIP. If we go with the cycle time, then the amount of elapsed time that a work item spent as work in progress. It's a particular cycle time over here. Definition, if we see of cycle time in terms of WIPs, that is the work in progress, removes much, if not all of the arbitrariness of some of the other explanations of cycle time over here that we may have seen or sometimes confused which kind of cycle time we need to consider, and gives us a, we can say, tighter definition of start measuring this particular metrics. The moral of this particular story is, if we essentially have control over when something is counted as per the work in progress in our particular process, take some time of define this particular policies over here around what it means for an item to be work in progress in our system, and start and stop our cycle time clock accordingly. With respect to work in progress, we need to find it out start and finish or start and stop point. And through this particular, we can say, analysis, we can find it out our cycle time clock with respect to work. So if we go with the work item age, this is the total amount of time that has elapsed since an item entered a workflow. Work item age referred as a WIP age, particularly, that is the work in progress specific age. We will try to be consistent in this particular, we can say, book from which we refer all this particular terminologies, and only use the term work item age. But if this two, WIP and WIA, is there interchangeably, then because of the work item age is a measure of current time in progress of all of our current work in progress. It by definition implies only two items that have entered but not exited the workflow. It defines all this. Once an item exits the workflow, then all the age that has accumulated up to that point immediately becomes converted the cycle time over here and measure of it. If we see throughput, this is the last of parameter we can say. Throughput, the amount of work in progress, that is the number of PBIs completed per unit of time, that's our throughput over here. Throughput is a measure of how fast item depart a process, the entry point and the departure of it. The particular, we can say it as a throughput. The unit of time that our team chooses for, we can say, our work. Throughput measurement is completely up to us. Our team can choose to measure the number of items that it gets done per day, per week, and per sprint. We can measure this particular throughput in the days, weeks, and the sprint. We can say unit only. It through if throughput is how fast item depart from a process, then arrival rate is how fast item arrive to a particular process. So this is a mandatory, and this is a, we can say, crucial unit of measures arrival rate and the, we can say, depart rate over here for a particular process. We mention this fact here because depending on our perspective, arrival rate can be uh, thought of as an analog of throughput here. The throughput metric answers the very important questions of how many PBIs is ongoing on the particular release or a next release. At some point, you're going to need to answer the particular question. So track throughput and be prepared. So here our topic is data collection and calculation over here. In terms of data collection, this is where us harping on us to define started and finished point will finally pay off. Take a timestamp when a PBI crosses our started point, and take another timestamp when the that particular same PBI crosses our finished point. This is a particular, we can say, boundary and the timestamp of it with respect to the started point and the finished point. This particular PBI crosses. do that for every PBIs that flow through our process, as he shown in the particular table. PBI's ID here, then started point and finish point. If we the particular PBI ID is one and started in for of 1st January of 22nd, then it finished on the particular same year of March, on March 1st. So second PBI is like that. The second February started point is it, and it finished on 3rd of March. Likewise, and so on. Some of the PBIs are here which started, but it yet to finish or yet to reach towards the finish point over here. Likewise, that's it. To calculate all the basic flow matrix, this is the only data we will need. Even better, if we are using some type of PBIs tracking tool. So tools are also available here, but for to follow or to process that particular tool, we which process this kind of, we can say, calculation, we need this much of data. We need a PBI IDs, we need the starting point, and we need the particular if the particular PBI with respect to ID it's finished, then we need a particular finish point over here to calculate a flow matrix of the, we can say, task. Here is a WIP work in progress, the count of all the PBIs that have started time stamp but not a finished time stamp for a given time period. Then we called it as a work in progress PBIs. Although technically WIP is an instantaneous metric, that is, at any time you could count all of the PBIs in process or our process to calculate work in progress. It is usually more helpful to talk about, we can say, work in progress over some time of units like days, weeks, and sprints. When the work in progress is completed, or within some particular days, some particular weeks, or some particular sprints. If we could want to know what our particular WIPs, that is a work in progress, was for a given day, we would just count our all PBIs which we had started but not finished yet date. Then we could find a particular, we can say, count of work in progress, we can say, as a parameter. Our work in progress, like guys, January 5th it started and its ID is 3. Then PBS 3, 4, and 5 have all started before 5th January but have not finished yet here. Now, if we go with the cycle time equals the finish date, and we can say reduce a particular started date and plus one. Like here, expression is given. Cycle time equals to our finish date minus starting date plus one. This is a particular, we can say, expression to calculate cycle time over here. If we are wondering where the plus one comes from the calculation, or where it comes, it is because we count every day in which the item is worked as a part of the total one. That's why the addition of plus one unit is here. However, as with work in progress, our very strong recommendation is to calculate cycle time in terms of days only. The reason is too numerous to get into here. So when starting out, calculate cycle time in terms of days, and then experiment with other time units. Later, we should feel like that we need them here, particular which is need to be calculated in a days only. Work item age equals the current date minus the started date plus one over here. Likewise, CD minus SD plus one. So it calculates a particular work item age and its particular workflow age here. So likewise, a throughput calculation with respect to this table, it's a different set. Throughput calculation, likewise, a work item we need, and then ID arrived and departed. This particular arrival and departed, we can say, days calculates our throughput. It's a sample data. To calculate throughput, begin by noticing the earliest date that any item completed and the latest date that any item completed over here. To calculate throughput, we need to have this kind of data. We need to have work item, we need to have ID, arrival, arrived and departed, then enumerated those dates with respect to this sequence. We have completed dates like 3rd of January, 3rd of February. With respect to a work ID, we have this particular started as well as finished item. Now, for each enumerated date, simply count the number of items that finished on that particular exact date, and it gives a throughput likewise. Like if we completed exact date work, we can say started, and we have like probabilistic date, and we put that date, then the throughput is one. If we not completed, then the throughput is particularly we can calculate here zero. And the starting just started, or the process which is in a process, then it is not completed, then we can say calculated here, because this particular throughput calculation depends on the completed date only. Now, throughput in terms of days, again, it would be a particular book itself where explain a justification of it. Through this reference book, we have two justification. Using days will provide you much better flexibility and granularity when we start doing things like Monte Carlo simulation for planning activities. This particular Monte Carlo simulation we explain in a particular slide in next section. And the second justification, using consistent units across all of our metrics, will save our lot of headache here. Likewise, so if you are tracking work in progress, cycle time, and age of particular work, then all of in a particular days or limited days, then we will make our life whole simpler with respect to the tracking of this into a scrum. Because throughput in days too, if we consider tracking work in progress, cycle time, and age in 2 days, then we get our work done in or likewise throughput in a days only. Then the whole calculation is simple, and we need to consider this in a days. So it's simpler in a particular sprint also. We can easily derive throughput per sprint from that particular data which is in days, if it still matters to us for a particular we can say calculation of throughput. The basic matrix of flow to get we started: work in progress, cycle time, work item age, and throughput. There are more certain other metrics that we will want to track in our own environment, but this represents the metrics common to all flow implementation. If our goal are improvement and predictability, then these are the metrics that we will want to track over the production. So now I hand over my work to Swapnil for probabilistic thinking. Now over to you, Swapnil.
Hello, very good evening. This side Swapnil Kantiwar from Team Axiom. So now I will start with the probabilistic thinking. So here we go. To thinking probabilistically means to acknowledge that there is more than one possible further outcome. The result of rolling two dice are completely unpredictable. Actually, there are several things that we know about each rolling. There is a 0% chance of rolling 1 or 13. The possible outcome are any whole number between 2 and 12. The most likely outcome of any given roll is 7. There is specific probability associated with rolling exactly 7. In fact, the chance of getting exactly 7 is well. Do we know the chance of this happening? So the flaw of average, anytime we communicate a forecast in term of an average, we have fallen victim to the flaw of averages. It stands for FOA. The flaw of average is a concept detailed in the book of the same name by Dr. Sam Savage, and is very closely related to probabilistic thinking. Simply put, the flaw of averages can be started as plan based on average, fail on average. The true power of flow metric for Scrum team comes in acknowledging their probabilistic nature. Now, every PBS that follows through our process will take exactly the same amount of time. Not every sprint will get the exactly same number of PBIs to done. So, embracing probabilistic thinking will allow you to make more accurate plans and will ultimately allows you to be more predictable for customers, stakeholders. But what are we thinking probabilistically about? What does probabilistic thinking have to do with flow metrics only? So tracking metrics on their own is of little use unless we have an effective way to display that data. The cycle time scatter plot and the WIP aging chart are two of a myriad of the analytical graph that we can employ for data informed decisions. In just that, these two will be most helpful and we talk about introducing flow of metrics into the Scrum events. Cycle time will be displayed in a chart known as scatter plot and the work time age will be displayed on the work item age aging chart. These two charts will be useful to us as we explore how to use flow metrics and Scrum events. So it's a cycle time scatter plot. As you can see in the image, the x-axis presents represents the timeline of your process. You will notice that in the figure, the timeline progression from left to right, this is not a requirement, it is only a preference. The upside of y-axis of a chart is going to some representation of cycle time. Again, you can choose whatever unit of time cycle time that you want from that axis. It can be days, weeks, months, etc. To generate a scatter plot, anytime a PBI is complete, you have to find the date that is completely across the bottom of plot, a dot on the chart as a height according to its cycle time. So the problem with the cycle time scatter plot, if there is one, is that by definition, a dot does not shows up until a PBI has finished. However, if a PBI is taking too long to finish, then waiting until it has finished to do something about it's too late. What we think, therefore, is a view into our process data while PBIs are still in progress. So PBM is the backlog. When the backlog is in progress, so it will be take too much time or it will be delay for completion of the backlogs. So we will call this view as the aging work in the process chart, progress chart. So the aging work in progress chart, it considers a process workflow that looks like this. The analysis active, analysis been done, the development active, the development is done, the testing done, whereas the analysis active is a started point and the done is a finished point. As you can see in the image, the age is the context is different from the cycle time on the scatter plot. What we are representing on this chart is the total elapsed time that an item has spent started but not completed yet, as opposed to the total elapsed time is took for an item to complete cycle time. So, however, it's just like a cycle time for an aging chart. We can use whatever time units we want, days, weeks, or months, sprints, etc. These every dots on the chart represents the project backlog item that has entered the process but not exited the process. To plot the dot, we simply find the workflow stage that is currently in and then subtract today's that from the item started and the recall uh, that we should have the track the timestamp for when the item entered our process. So tracking metrics on their own is of the little use of unless we have an effective way to display the data. The cycle time scatter plot and the WIP aging chart are two of the myriad of the analytical graphs that we can employ for data informed decision. It's just that this too will be most helpful as we talk about the introduction flow metrics into the Scrum events. So this is the first part of the sprint planning. As Scrum is only a framework, it guides the purposefully work on how sprint planning should actually be accomplished. And as most who are reading this manuscript know, much has been published on proper techniques to plan a sprints. So how do we take a probabilistic approach to sprint planning? The Monte Carlo method stands for the MCS, especially it is a statically sampling technique where a simulation is used to predict the probability of different outcomes given the input and the random variables. Once a candidate sprint goal is found, the developers are being asked to forecast how many project backlogs items are they will be get completed in this duration of the sprint. So given all of the possibility variables associated with forecasting something like that, dependencies, interrupt, the pandemics, etc., there is only a one way, there is a no way you could reasonably come up with an equation like E equals to mc square that will adequately model a solution of this problem. Monte Carlo method varies, but it's a general. They tend to follow a typical pattern. There are four: define a probabilistic distribution of possible inputs, randomly select values from the input distribution, and the perform a computation on the selected inputs, aggregate the result, repeat step second and the arbitrary number of times until you have a clear picture of what the result set looks like. So we before going to the fourth step, we need to be in the completion of the means the second and the third step. The randomly select value from the input distribution and the perform a computation on the selected input and the aggregate the result to show the historic result usually. So this is the sprint planning for the part two. The Scrum team may refine this item during this process, which increase understanding and the confidence. The question from most Scrum team is how much refinement is enough refinement. We want to know what project backlog items can be done in the next sprint. A solution to this problem is straightforward. Feed historical throughput data into the MCS and they interpret the result to make probabilistic forecast about what can be done. So the fundamental assumption when using a Monte Carlo simulation, Monte Carlo method simulation for sprint planning is that the further that we are trying to forecast roughly looks like the past that we have data for. One of the big advantage of using Scrum is that if you are following the framework professionally, then you will generally save to use the past data for the further predictions. In a very short amount of time, you can get a very accurate forecast of what you can be done in the sprint, thus allowing you to quickly focus all of your attention on what is the important actually doing the work. So the daily scrum, it is the very important part. The daily scrum is perhaps the events most actively impacted by using flow metrics, while the sprint planning is dramatically shorter with these tools. The nature of that event doesn't change all that much. We still figure out a sprint goals and trying to forecast what work can be delivered to reach that goal. With the daily scrum, however, we see a change. A goal of the daily scrum remains the same, inspect progress towards the sprint goals. But with the use of flow metrics, the conversation changes from how do we work together today and help each other reach the sprint goal, and also the how old is this stuff and how can we get it moving, means how can we overcome from that. Using flow metrics in our daily scrum actually encourages more teamwork by focusing on the work to be done, because when the work moves and gets done, we will get a feedback. We will need we need to actually inspect our progress towards the sprint goal, and not just the stuff you think you need to be delivered. So the sprint reviews, the flow matrix allows you to switch the conversation to a more further pacing one. Many teams still struggle with running demos with everyone's present correctly. Feels like this is a waste of time. Well, isn't due to a simple lack of knowledge on what the event should be about. It's mainly due to fact they can relay say anything about the future will not anymore because now we got the measures, charts and answers to most pressing question of our stakeholders. The sprint retrospective. Data without action is meaningless. The purpose of our retrospective is to improve our overall process over time. Metrics are just one, but important piece of that. As we will go into our next sprint retrospective, remember that our pos- policies shape our data and our data shapes our policies. And the toolings. Tools can be great help or a great hindrance. The final tips we have means the like to share is to start simple. Don't rely on a tool to compensate for a lack of knowledge or discipline in a team. Get to a point where our team has achieved flow in their delivery and find a tool that supports that flow. So this was a simple demonstration by the team Axiom, and these are the some references which the team has referred. That's it. Thank you. Over to sir.
Hey, it's a wonderful explanations about the entire Scrum related various flow matrices while dealing with the project managing. And I hope the things are clear. What kind of Scrum ceremonies and the entire process of Scrum uh, need to be performed during project execution, right from the planning to execution to delivery. So to have discussions on various such topics, do contact us, write some comments or give us the like suggestions where my team can able to uh, generate the various the proper documentation and analysis, and then give the explanation so that everyone can get an opportunity to understand that technical requirement or the analytical requirement, and together we will be able to provide the base to the industry, right? Hope you enjoyed these sessions. To have such more sessions, do contact us and keep in touch. Thank you. Have a great day ahead.
Yeah, thank you, sir.